if my position was 36, first thing I have to do is subtract so 36 so I got 2.6 seconds. Now, that makes sense to me, because this was the position at 2, this was the position at 2, this is the position at 3. Midway between there should be around halfway, but again, it's a cubic function, so it doesn't have perfect symmetry here. So it's at 2.6 seconds. So then, let's apply our algorithm again, or apply our equation again. So V is equal to 4.5 times 2.6 squared. So then you get the velocity when it's midway through, and it should be close to all these. Last one says graph x versus t and indicate your answers graphically. All right. So we know a couple things. So we know the position at 2 seconds, we know the position at 3 seconds, we know the position at 0 seconds, because if time is equal to 0, it's 9.75. So just if we just graphed those three, okay, if I make this 50, 3 seconds, 2 seconds, 1 second, if I go to plot at 0, it's at 9.75. At 1 second, well, at 1 second it's 1.5 plus 9.75. That's a little bit more. It's only 1.5 up from there. At 2 seconds, it's at 21. 3 seconds, it's at 50. And what I like about this is this gives us a really good sense of the velocity, because the velocity at 2 seconds was 18. It's not very shallow, but the velocity at 3 seconds was 40. It's much more shallow, and in between here it goes from there to there. Next problem I want you to do is 21. From time t equals 0 to t equals 5 minutes, a man stands still. Oh, I don't have time to do this one.